Okay, so for today's lesson, we are going to be solving quadratics using the graphing method. We are going to learn to solve quadratic equations by other methods, factoring, taking square roots, completing the square, and the quadratic formula. But today we're going to focus on the graphing method. And the solutions to a quadratic equation are also called your x-intercepts or roots. So we're introducing new vocabulary. So all of these words mean the same thing. Solutions to a quadratic equation can also be referred to or called zeros because this is where your equation equals 0. And that means y has a value of 0. So you're trying to figure out what are the values for x that will make my equation have a total overall value of 0. So the words you need to know, when they say find the solutions, they are telling you to find the roots. They are telling you to find the zeros, which means you're finding the x-intercepts. What are those x values where y has a value of 0? And you can look at the graph along the x-axis to find those x-intercepts, or find the zeros, or find the roots, or find the solutions. So some look-fors when you are graphing. You can look at your quadratic equation just like you could look at a system when you graphed it and tell how many solutions. For a quadratic equation, you're going to look at the x-axis. If your function crosses the x-axis 2 times, has 2 x-intercepts, you are going to have 2 solutions. If your quadratic equation only touches the x-axis once, and this would be where the vertex touches the x-axis, and you have 1 x-intercept, you are going to have 1 solution. If you notice that your quadratic equation does not cross the x-axis at all, then there is no real solution. Now, you will be able to find the solution, but you will learn that process in Algebra 2. Right now, we would just write no real solution because you have no x-intercepts. It does not cross the x-axis at all. So here you can see the x-axis, your vertex, no part of your parabola crosses the x-axis. So 2 x-intercepts, 2 solutions. 1 x-intercept, 1 solution. No x-intercepts, no real solution. So now we're going to look at how do I solve by graphing. So the first thing you want to do is set each equation to 0 by moving each term to one side. So if all of your terms are on one side, then you are ready to go to solve your equation. If not, you're going to have to do some rearranging. You're going to type your equation into y equals, and you're going to make a table. You want to look for your vertex, and I'm going to talk about Oreo here in a minute to help you find your vertex. You're going to graph using the points, and you want to make sure that you see where y is equal to 0. That's where you have your zeros, your roots, your solutions, your x-intercepts. So our first 2 examples. Find the zeros of the quadratic equation by graphing. So the first thing I'm going to do is make sure that all of my terms are on the same side of the equals. And I have x squared minus 2x equals 3. So I'm going to move the 3 over to be on the same side of the x squared and the negative 2x. So when I move it over, it's going to change it to a negative 3. So my equation is now going to be x squared minus 2x minus 3 equals 0. And remember, that 0 is me replacing y with 0. So it's really equal to y, but because I'm trying to find my x-intercepts, y has to have a value of 0 when we're looking for x-intercepts. So now I'm going to get my calculator, I'm going to turn it on, make sure my memory is cleared, and I'm going to go to y equals, and I'm going to type in x squared minus 2x minus 3, and I'm going to go to my table of values. And I'm just going to pick some numbers. So when x is negative 2, y is 5. When x is negative 1, y is 0. When x is 0, y is negative 3. When x is 1, it's negative 4. When x is 2, it's negative 3. When x is 3, y is 0. And when x is 4, y is 5. And so I'm going to go ahead and, looking for my vertex, I'm going to look for my Oreo. So I can see that when y is 0, x is negative 1. And when y is 0, x is 3. Now my vertex point is going to be in the middle, halfway between my two zeros. So I can see I have two -3s, -4. So this point right here, 1, -4, that is my vertex. So that's either going to be the highest or lowest point on my parabola. So I'm going to go ahead and plot that. So I'm going to go over to 1, -4. And now I'm going to plot my 0, -3, 2, -3. I'm going to plot -1, 0, and 3, 0. And I'm going to go ahead and plot -2, -5, -2, 5, I'm sorry, and 4, 5. And I'm going to trace these, and you can see it does make that curved graph, so we are no longer drawing straight lines. And you can see that this is my vertex point. It is the lowest point on my graph. Vertex can also be the highest point. And you can also see that I have solution. There's a solution. There's another solution. So I cross the x-axis, I have two solutions. So my solutions are x has to be equal to a -1, -1, and x has to be equal to a +3. Those are my solutions to my equation. And so now I'm also going to practice writing the domain and range. For your domain, on any quadratic, it's going to be all real numbers. Because when you go to the left, you get an arrow, so it's going forever in the negative infinity direction. And then when you try to figure out how far right it goes, you run into an arrow when you're going to the right on your graph, which tells you it keeps going. Even though it looks like it's going up, it's also going out, very, very small. So now I want to look at my range. What is the lowest that my graph goes on the y-axis? So I go down my y-axis until my graph is stopped being drawn, and the lowest it goes is -4. So I know it won't get drawn below -4, and then from there it's going to go up. Well, if I travel up my graph line, I'm going to run into some arrows, so it's going to go to positive infinity. And so the lowest it goes is 4, and it never stops getting bigger. So my range is y is greater than or equal to -4. And the reason why it's greater than or equal to is because I have a solid point. And so now we're going to look at the next example. So again, we're going to set each equation to 0 by moving each term to one side. So I've got -x² plus 2x equals 1. So what I'm going to do is I'm going to move my 1 over to be with all my other terms. And I'm going to get -x² plus 2x. When I move the 1 over, it's going to have a sign change. So -1 equals 0. Now remember, that 0 is really y, but because we're looking for an x-intercept or a 0 or a root, y has a value of 0 on the x-axis, or when we were on the x-axis. So now I'm going to go to my calculator, and I'm going to go to y equals, and I'm going to type in my equation, -x² plus 2x minus 1, and I'm going to go to my table, and I'm going to start filling in. So I'm going to move my paper over a little bit. So when x is a -2, y is a -9. When x is -1, -4. When x is 0, it's -1, 1, 0. 2, -1. 3, -4. 4, -9. Okay, so I'm going to start looking at here. I see a 0, but I only see 1, and if I even go up and down my calculator, I'm getting more negative as I go down, and if I go up, the same thing, my y values are getting more negative. So I'm going to go ahead and plot this point because it looks like I only have one x-intercept, which may mean I only have one solution. So I'm going to go to 1, 0 here, and now I'm going to plot my points. I'm going to go to -2, -9, -1, -4, 0, -1, 1, 0, 2, -1, 3, -4, and 4, -9. And because of how my graph line is drawn, my parabola, it is flipped upside down, so it's a reflection, and I only have one x-intercept, which also happens to be my vertex. It's the highest point. Last time it was the lowest point, now it's the highest point. So I only have one real solution, so my solution is when x is equal to a +1. So those are my solutions. That's what I'm trying to find. I'm trying to find those x values because that's where my graph crosses the x-axis. So again, I'm going to write my domain and range because we're going to practice that. For a quadratic, the domain is always all real numbers. For my range, the lowest that it goes, well, if you look down at the bottom, if I travel down the y-axis, I never stop going because I run into arrows, so it's going to -infinity. So let's see how high it goes on the y-axis. So remember, domain range is y. So the highest it goes is right here on the y-axis, which is 0, and then it goes down from there. So the range is y is less than or equal to 0 because it starts at 0 on the y-axis and it goes down from there, and I'm including a solid line because I have a solid point right here at 0. All right,